Now, if I have another system, I have a, let's say I have a center system. So this is my lattice, and then I have a center 2 by 2. This would be my 1 by 1. You also get 1 by 1. And my center 2 by 2 can be drawn like this, a sort of rectangle with a center spot, or you can draw it like a diamond struck like this, because you can picture it. I can redraw like this way. Okay, and likewise you can generate a different reciprocal net pattern like this. All right, so you can see what I'm trying to say is that you can define A and B, right? A and B. Then it can convert using this formula that we got. You can convert it to be A and B like this. Okay, so if I go, if this is my A and B, right? I can define A and B, these two vectors like that. All right. So all I'm saying is that you can do a mathematical transformation, and it's very precise because if you have a real space point, vector point between these things, you can generate the corresponding point in reciprocal space. Okay, so that's point number 1. And point number 2 is that, of course, you have to define them because it's mathematics, right? Because they don't in this case, if A is here, right? If this is my A vector, then in this case A would also be here. So I should really draw A like this, right? In the same direction. But in this case, if A is here, right? I have to think because I have to think about that there's a cross term, right? So my A vector may not be in this direction. My A vector could be let me see. So this is this would be kind of like 1, 0 spot. One is set 2, 0, but it's the same direction of 1, 0. So it could be along this way. Along one of these directions. It could be along this way. Okay. I don't really know which one, except in order to know it, I have to do my calculation. But you can see what I'm trying to impress you is that in this case, the residual space net don't point in the same direction as the real space net. In the case of a square, it points in the same direction. Okay, so in order to know which direction of the vector to go, you really have to do this calculation, which is the cross product. Okay, now so that's one thing. That's just scaring off your substrate net that you have, right? You diffracted off this grid that you got. Now what happens if I put some absorbate on top, right? So you can think of this either as my the top layer of my substrate. Remember, for clean surface, remember how I define my substrate. My substrate is the is the part of your material that had 3D periodicity, and then the cell edge was on top of that. We usually have a couple layer of atoms with changing d spacing. Okay, and that cell edge I call either overlayer or cell edge, right? So think of this as the ideal termination of your substrate. Now, another way to think of this is that I can think of this as the top layer of my cell edge, right? And then I can put my atom on top, like absorb it on top. Okay, so let's see what happened, right? Because here we have a top layer of my original grid, and now I populate this grid. I put, let's say, sulfur atom on nickel. This is my top layer of nickel surface, and I put my sulfur atom. And sulfur atom can go anywhere. It can either go on, let's say, a top site on top of the nickel atom. It can go into bridge site between two nickel atoms, or it could go into 4-4 hollow site, you see. And they can arrange in such a way that they have periodicity among them. If you populate a monolayer of sulfur atom on top, right, they could arrange also in a pattern, because they always go into, depending on the energy that they can achieve, they always go into the same local site. So if some atom prefer 4-4 Hall site, then you populate all the 4-4 Hall site in that way. So then your absorbate will generate another periodicity, isn't it? Because it would then generate a two-dimension geometry on top of your original substrate. And this in part C is what I'm trying to show you. So here we have, again, like A, I have the original circle, open circle, as my original substrate point. And now I put in my atoms, let's say my sulfur atom as my crosses in here. And you can see that I put in my sulfur atom in a certain pattern. You can see I put it in the center point of these, ordinary center point. And this is known as the C2x2 pattern because every 2 units I have a center spot. Okay, you see the spacing between here and here, right? Is if I call this spacing let's say call it I don't want to call it. Let's call this one A spacing. Then this, the separation between two crosses is 2A, isn't it? Right? And if I call this one B spacing, then the separation of this is 2B, isn't it? And because, so this would sort of be my unit cell, but then I have a center spot in this unit cell. So this is a center 2x2, okay? Because this here, right, will be my 1x1. Here I have twice as long. It becomes 2x2. Remember how we define twice as long with respect to my original grid. And because I have a center point in my square, is the center 2x2. Okay, now, so that's real space. What do you see if you do diffraction in reciprocal space? So now I go to reciprocal space. First of all, I will see my substrate spot. All this open circle will generate bright, dark spot like this. Okay, so those on the lead parent, they will appear as bright spot. Okay, now if you populate this with sulfur atom, what will you see? You're starting to see little faint spot in the middle of these bright spots, like that. So these are little faint spots. So if you think about this bright spot are the indigo order spot. So they all, if you define this diffraction B as 0, 0, this become 1, 0, this becomes 0, 1. And these in between spot, weaker spot, are called fractional diffraction spot because they are now, this in reciprocal state they are called half and half, and this one will be half and minus 1/2 and minus half, and so forth, right? So, so what is the lesson? The lesson is that, well, if you have the overlay spot is twice the distance, right? Your actual vector in reciprocal state should be 1/2 of that. Okay, but you say, well, this look like it's the same, but that's not true. It's not true because really what happened is that you also, even for the weak spot, you also have spot on top of this bright spot. You just don't see it because the bright spot overwhelms the weak intensity. So really, so let me try to, what you think, you only see the weak spot because there was no intensity there before. If you generate your pattern corresponding courses, all your spots should be here. You also have a spot in the middle and all the black spot as well. In addition to all the black spot location, you also have weaker spot on there. But you don't see those weak intensity. The reason is because there was already intensity there on the black spot due to these guys, due to original substrate, you see? So that's why you don't see any additional weak spot because the bright spot overwhelmed the weak spot. So you really should count, right? You really should count the spacing from here to here, okay? And that's why, so if this is 1, 0 spot, this is my center 2x2 spot. It really is 1/2 the spacing of the original.